In this video, we'll speak about what is a discrete random variable. Before we start, what is discrete random variable? Let's see if we flip a coin 3 times. The sample space of this probability experiment will be that we can have 3 heads. We can have head, head, tail, or head, tail, head, or tail, head, head, or we can have 1 head, 2 tails, or we can have 3 tails. So the number of elements inside the sample space, or the number of possible outcomes of this experiment, is 8 outcomes. Let's say, for example, the second outcome here, that's mean that the first flipping time is head, and the second is head, and the third is tail. If we define something called x, where x here is the number of heads after flipping the coin 3 times. Of course, x can be 0, that's mean no head appear, or x can be 1, that's mean we have 1 head, or x can be 2, we can have 2 heads, or x be 3, that's mean we have 3 heads. You see here in each value for x represent a certain event that can be happened from the sample space. X equals 0 means no head, that's mean we have tail, tail, tail. X equal 1 means we can have 1 head, and that's mean we have head, tail, tail, or tail, head, tail, or tail, tail, head. We have 1 head. X equal 2 means 2 head, that's mean we have head, head, tail, or tail, head, head, or head, tail, head, head. And the x equal 3 means have head, head, head. X here, of course, it is a variable because it don't have a constant value, maybe 0, 1, 2, 3, so it's a variable. And also it's a discrete variable, discrete because its value is a discrete value, 0, gap, then 1, gap, then 2, or because its value can be listed as 0, 1, 2, 3, so it's a discrete variable. And also it is a discrete random variable because this variable x is coming from a certain random experiment which is flipping the coin 3 times. So x here is a discrete random variable. So the discrete random variable is a certain variable that have each single value is a certain outcome of the random experiment. And when we list all the values, all the possible values for x, we define the whole experiment or the whole outcomes in the sample space. And the random variable is called discrete if take its values from a discrete data, like our example here, 0, 1, 2, 3, so it's a discrete value. Of course, each discrete random variable have its possible values, which we called xk, and here x1, x2, x3, x4 is the possible values for x, and the probability bk is the probability that each value happened. So the probability that x equals 0 means, probability that x equals 0 here means the probability of having 3 tails after flipping the coin 3 times. And this probability we can count it directly from the sample space. That's a one case out of 8 cases, so it is 1 over 8. The probability that x equal 1 means probability that we have one head out of 3, out of the flipping the coin 3 times, so it is 3 over 8. And the x equal 2 also will be 3 over 8. We have 3 cases for 2 head, and the x equal 3 be 1 over 8 because we have one chance to have 3 heads out of 80 chance. Of course, if you sum all the probabilities pk, it must equal to 1, and it's one of the important property for the discrete random variable, that is the sum of all the probability of its possible value must equal to 1, because all these possible values describe the whole sample space, and the probability that the sample space is happened is a certain event, so its probability is equal to 1. So now, if you think what is the discrete random variable is, a discrete random variable is a certain variable x that has a certain numeric values. Each numeric value define a certain outcome of a certain random experiment. And if we have the sample space with discrete outcomes, then the random variable x is called discrete random variable. And each discrete random variable, we can describe a table containing the possible values for x, which is called let x1, x2, and so on until xn, and calculating the probability for each value, let's say is p1, p2 until pn. And the first property we have that the sum of these probabilities from 1 to n must equal to 1. This table is called the probability distribution of this discrete random variable. And now we need to learn that if we have this probability distribution, how to define 4 properties for the discrete random variable. The first one, what is called the probability mass function, and we write it as PMF. What is called the cumulative probability function, CPF, and what is the expected value of x and its meaning, and what is the variance and the standard deviation of x. So for each discrete random variable, if you know its probability distribution table, you have to define its probability mass function and draw it, its cumulative probability function and draw it, and calculating the expected value of this random variable and the variance of this random variable. Now, to see how to define the 4 property we mentioned for any discrete random variable, which is the probability mass function, cumulative function, expected value, and variance, let's see the example that we need to check the number of boys in a family having 3 children, and let x is the number of boys inside each family of 3 children. Of course, the sample space of this experiment, we can list its outcome, and we have here 8 outcomes, because if the family has 1 child, it may be a boy or a girl, so we have 2 outcomes. And as we have 3 child, the number of elements inside the sample space, it will be 2 power 3, so we have 8 outcomes. The 8 outcomes is boy, boy, boy. Let's have 3 boys, or we have 2 boys and 1 girl, and maybe the 1 girl is the first or second or third child, or we have one boy and two girls, and the one boy may be any one of the three child, and the eighth outcome that we have the three children as girl, girl, girl. Now we have 8 outcomes, and as we define the random variable x is the number of boys, now we need first to make the probability distribution table for x. Of course, from the definition of the random variable and from the probability experiment defined here, the possible values for x is x equal to 0, 0 poi, 1 poi, 2 pois, and 3 pois. So the probability distribution table that we have 4 possible values for the random variable x from 0 to 3, and the probability of each value we can calculate it from the listed sample space we have, that x equals 0 means we have 0 boys, that means we have 3 girls, and this one case out of 8 cases, so the probability is 1 over 8. The probability that x equals 1 means we have 1 boy, and we have 3 cases with 1 boy, so the probability is 3 over 8. The probability that x equals 2 means we have 2 boys, and also we have here 3 cases, so it's 3 over 8. And finally, the probability that x equals 3, that we have 3 boys and it's 1 cases out of 8. To check the probability distribution we have, of course, if we sum these probabilities starting from k equal 1 up to 4, because we have x1, the possible values, first possible value, x2, x3, and x4. If we sum the 4 probabilities, we find that the sum of this probability is equal to 1. Secondly, for the same random variable x with the number of boys, we need to define what is called the probability mass function. And the probability mass function is given the symbol f small of x. And the probability mass function is a function taking an argument value for x, and the output of the function is the probability that our random variable is equal to this x. That's mean when I said f of 0, it's a function returning the probability that the random variable is equal to 0, and that's equal to 1 over 8 from the probability distribution table. The probability that f of say 2, that means the probability that the random variable is equal to 2, and that's equal 3 over 8. And finally, f say of half is the probability that x equal to half, and of course that's an impossible event that we have half boy in a family of 3 children, so this probability is equal to 0. F of 5, that means the probability that x equal to 5, and again it is impossible to have 5 boys in a family of 3 children, so it's also equal to 0. You can now think that the probability mass function will return a number not equal to 0, when its input value is one of the possible values for x, otherwise it returns a 0. That means that any probability mass function will return one of the probabilities pk of the probability distribution table if the input x is one of xk, and it returns 0 otherwise. If we need to draw this function, it will be a discrete function. A discrete function means it only will have a value at x equals 0. It's have a value 1 over 8. At x equal 1, it's have a value 3 over 8, and x equal 2, it will have a value 3 over 8, and at x equal 3, it will have a value x equal 1 over 8, and 0 otherwise. And if you look at this graph, that's x and that's f of x, you will see that each probability here is represent the mass of each value. That's why it's called the probability mass function. And also it represents the distribution of the probability. We have in this probability 1 over 8 and then 3 over 8 and the same 3 over 8 then again 1 over 8. So as x increased, we see the distribution of this value. So the function of the probability mass function is representing, the probability mass function is the probability that x is equal to the input of the function, and it has two cases. It returns the probability in the distribution table if x is equal to x, and or 0 if the input is any other value, not one of the values of possible values for x. Thirdly, for the same example, which is x is the number of boys, we need to define another thing, which is a cumulative probability function. And it's the second function associated with x. The first one, which is called the probability mass function. The second one is called the cumulative probability function. And it is given the symbol f capital of x. And the f capital, its definition is, if we have an input x, it returns a probability that x is less than or equal this input value. So if we have a certain input value, it calculates the probability that x less than or equal x. So if I said f of 1 is the probability that x is less than or equal 1. And of course, less than or equal 1 means in x equal 1 or x equal 0. So it will be returned x equal 1, the probability that x equal 1, plus the probability that x equal 0. X equal 1 is 3 over 8, and x equal 0 is 1 over 8. So finally, f of 1 will be 4 over 8. If I say, for example, f of half, it's the probability that x less than or equal half. And x less than or equal half, not equal to 0. It is less than or equal half, so we will have the probability that x equals 0. So it is 1 over 8. If I say f of 4, that means that x less than or equal 4. And for our example, less than or equal 4 means we will sum all the values of x. So it is 1. And you can see that if I say f of negative 1, that means the probability that x less than or equal negative 1, and it's a possible event which is equal to 0. You can think now that if the input given to this function is less than the first possible value for x, it will return 0. But starting from the first value for x as an input, it will start to return the probability, and this probability will increase as we go on until it reaches to 1 at the last value of x. That means that the cumulative function for our example will return 0 if it have a certain input which is less than 0, and 0 here is the starting value for x. If you giving an input which is less than 0, it will return 0 value. But if you give a 0 as an input, it will start to give the probability which is 1 over 8, which is the probability of the first value of x. And if you give an input, any input between 0 and 1, where 1 here is the second possible value, it is still 1 over 8, because as a cumulative you add nothing until you reach to 1 exactly. So f of 1 here is the probability of 1 and 0, so it will be 4 over 8. And the 4 over 8 here is the sum of 3 over 8 plus 1 over 8 until you reach to 2. And then again, when we reach to 2 while adding the probability of 2, which is 3 over 8. So we will reach to 7 over 8 until 3. And because 3 is the last possible values for x, so starting from 3 and above, we adding all the possible value so to reach to 1. From the properties of this function, that it starts from the value 0 before the start value for x, and each jump is happened at certain possible values for x until it reach 1 at the last possible value for x. If you need to draw this function, of course this function will have a certain jump values at each possible values for x. In our example, the possible values is 0, 1, 2, and 3. So for any input less than 0, the probability is 0. At 0 exactly, the probability having a jump with 1 over 8. So we have 1 over 8. And this value is constant because we add nothing until we reach to 1. And at 1 exactly, we will add 3 over 8. That's mean we will be at 4 over 8. And this value will be constant until 2. And at 2 exactly, we'll have another jump with 3 over 8. So it will be 7 over 8. And this value will be constant until 3. And then at 3, we have another jump to reach 1. And this value will be constant for any other value of x. So it is now a certain cumulative function. We cumulate the probability, but since we are dealing with a discrete random variable, nothing will be added until we reach a possible value with a certain mass. So we add its probability, and again it will be constant until another value, and add its probability until 1. So every time we will have a certain step, and each step is happened at a possible value for x with the value of its probability. It must start with 0 and reach at the end to 1, and between the probability with 0 and 1 we'll have a certain jumps. Fourthly, we need to define what is called the expected value of the discrete random variable. The expected value of the discrete random variable is sometimes called the average value, or the expectation of the value of x that we have, or on average, what is the expected value of x. In some time it's called the mu, and in other time it's called the expected value for x. The expected value for x. The expected value, you can think of the expected value that is a weighted probability value. And each weight, the weight is the probability of each value. We have, for our example, 4 values for x equal 0, or x equal 1, or x equal 2, or x equal 3. And the x equal 0 having a weight probability 1 over 8. X equal 1 having a weight probability 3 over 8. X equal 2 having a weight probability 3 over 8. And the x equal 3 having a weight probability 1 over 8. So the expected value of x is the sum of each value with its weight. And finally, the expected value of x will be 1.5. So we are expect that out of this family of 3 children, we have 1.5 points. Of course, this value 1.5 is the average value between 0 and 3, because we have a certain symmetry in the distribution of x. If you remember, when we draw the probability mass function, we have a certain distribution. It have a value here 1 over 8, 3 over 8, 3 over 8, 1 over 8. And this distribution has a certain symmetry about the value between 0 and 3, which is 1.5. That's why we have the expected value of x is 1.5. In general, the rule of the expected value of x that we multiply each value of x times each probability and then having the average or the sum. Again, you can think of the expected value. It is a weighted average of the random variable values for x, and each value is weighted by each probability. Finally, what is the variance? What is the variance of a discrete random variable? The variance of a discrete random variables is the average spread of its discrete random variable around its expectation. It is the average spread of the values of x about each expectation. That means that each value, how much each value is difference between the expected value, and we get the average using the weight of the probability of this spread of each value times the mean. That is called the average, and the average of x is giving the symbol sigma squared, or sometimes it called the variance of x. And if we expanding this bracket, we will have another form for the variance. The variance is the value squared times the probability with the sum minus the sum of, minus the mean squared. Or in other way, it is written as the variance of x is the expected value of x squared minus the expected value of x all power 2. And the difference between the two terms that in this term we sum each value squared times the probability, but in the second term we multiply each value by the probability, and then finally we get the square. Let's see for our example. You remember that we have 4 values of x with probabilities 1/8, 3/8, 3/8, 1/8. So to calculate the variance of x, we multiply 0 squared times 1/8 plus 1 squared times 3/8 plus 2 squared times 3/8 plus 3 squared times 1/8, and that is the expected value of x squared, or each value squared times the probability, and finally we minus the mean we calculated, which is 1.5 squared, and we will have the value of the variance square, and this value of the variance square will be 3/4, and finally the standard deviation for x is the root of the variance, and it will be root 3/4, which in decimal value it will be about 0.87. To sum up now, in this video we speak about that if we have a certain discrete random variable, this discrete random variable having a certain possible value x1, x2 until xn, and these random numeric values we calculate for each value its probability b1, b2 until pk. And for any discrete random variable, if we have its probability distribution table, we can define 4 properties. The first one is called the probability mass function, f of x. And this probability mass function is the probability that x equal to x. And if have 2 cases, it is the probability that x equal k if one of the input is xk, or it's 0 otherwise. Secondly, we define the cumulative probability function, which is f capital of x, and the definition of f capital of x is the probability that x less than or equal x. So if I have an input x, we adding the probability of this x and all the less than, so it's called the cumulative probability function. And this function is starting from 0, ending with 1, and having a jump b1, then p1 plus p2, and so on until 1. And we define what is the expected value of x, or mu, and we call that it is the average of sum of each value of x weighted by its probability. And finally, we define the variance of x, which is the expected value of x squared minus the expected value of x all power 2. And then finally, the standard deviation is the root of the variance. So now, for any discrete random variable coming from a certain probability experiment, you can imagine its probability distribution table. And from this table, you can define two functions associated with x, which is the probability mass function, cumulative function, and also you can calculate the expected value and the variance of x using the probability distribution table. And one of the important property of any discrete random variable is that the sum of the probabilities must equal to 1. In the next video, we will see other examples about the discrete random variable and its property. Thank you.